In this class, I want to discuss some problem on Poisson distribution. So let us start with the example. The number of monthly breakdown of a computer is a random variable having a Poisson distribution with mean equal to 18, 1.8, with mean 1.8. Then find the probability that this computer will be function for a month, and the conditions are without a breakdown, without a breakdown. Second is with only one breakdown, with only one breakdown. And the third one is with at least one breakdown. So this is your question. Now we have to find the probability that there is no breakdown in a month, and then with only one breakdown in a month, or at least one breakdown in a month. So before going to the probability statement, let us define our random variable. Let x be the random variable of breakdown of computer in a month. Okay, this is the random variable associated with breakdown of a computer in a month. Then what will be the probability statement of this? Probability of the without a breakdown, that means x equal to 0. What is the probability statement of second one? With only one breakdown, that means probability of x equal to 1. Then what will be the third one? Third one will be the probability of at least one breakdown, that means x is greater than or equal to 1. That what does it mean? We can find probability of x is less than 1, complement to that one. So now we will apply the Poisson distribution, and we will try to find the probability corresponding to no breakdown, one breakdown, at least one breakdown. So here my r is nothing but 0. Okay, and lambda is nothing but, so how can we find? Here we have lambda equal to 1.8. So lambda equal to 1.8, and in this no breakdown r equal to 0. So e to the power minus 1.8 into lambda to the lambda is equal to 1.8 to the power 0 divided by 0 factorial. So if you simplify it, you will get it e to the power minus 1.8, and that is equivalent to 0.1653. 1653. Similarly, this one will be x equal to 1 means r equal to 1, e to the power minus 1.8 divided by 1.8 to the power 1 divided by 1 factorial, and that will be equal to 1.8 into e to the power minus 1.8. So that is equivalent to 0.2975. Okay, and this one will be 1 minus less than 1 means the probability x equal to 0, and so 1 minus 0.1653, that will be equal to 0.8347. So like this we can able to find the probability for a given random variable x following the Poisson distribution. Now I will take another example here. Example, it is known that it is known that the probability of an item, the probability of an item produced by a certain machine will be defective is 0.05. So this is the probability of producing a defective item. Probability of producing a defective item. Okay. If if the the produced item are sent to market in a packet of 20, in a pocket of 20 20, then find the probability, or find the number of packets containing at least at least exactly and at most two defective items in a consignment of 1000 pockets. Use Poisson distribution. Using Poisson distribution. Okay. So now here, what is the item? What is the question given? Actually, one company, one machine is producing some product. Okay, some items. In that case, the item will be defective is 0.05. The probability of the defective item is 0.05. Now, in he produced the items and he sent to market. In one packet 20 items are there. Then the question is asking, find the number of packets containing at least exactly at most two defective items in a consignment of 1000 packets. So what we will do here, let x is the random variable of defective items. X is the random variable of defective items. Then we will write the probability statements and again, and P getting the defective item is 0.05. Then Q we need not to do here because lambda will find n into P. Okay, so what we will do here is we will write the probability statement of first one. What is the first statement? Pocket containing at least two defective item. At least two defective item means probability of x is greater than or equal to 2, and that we can say 1 minus probability of x is less than 2. X is less than 2. Okay, and then second probability statement is exactly 2. Probability of x equal to 2. And third question is at most probability of x is less than or equal to 2. So we need to find these probabilities. We need to find these probabilities. So here one hint is given, use Poisson distribution. Poisson distribution we have to apply and we have to find the probability of these things. So you know that Poisson distribution P equal to x equal to r. Probability of x equal to r will be nothing but e to the power minus lambda, lambda to the power r divided by r factorial. Now we need to find lambda. We need to find lambda. So how can we find lambda? Here lambda equal to n into p. But what is your n? N is 20, and what is the corresponding probability? 0.05. And so finally what is the answer? What is the mean? Mean will be nothing but 1. And here we are having capital N equal to 1000. Capital N equal to 1000. Okay, so now we will find the probability one by one. So let me first start with the second one because that is easy. Probability of x equal to 2. In place of r I am having 2. So I will write e to the power minus 1 into 1 to the power 2 divided by 2 factorial. And so e to the power minus 1 by 2. And that will be equal to 0.1839. If you simplify it, you will get it. Now let me go to the less than. So third one I will do. Third one will be probability x less than or equal to 2, and that is equal to probability at x equal to 0 plus probability at x equal to 1 plus probability at x equal to 2. And so finally what we will get? Here we will get it like this. X equal to 0 means r equal to 0, so r equal to 0 is nothing but e to the power minus 1 plus Probability at x equal to 1 means nothing but e to the power minus 1 into again 1 plus probability x equal r equal to 2 means e to the power minus 1 lambda to the power 1 to the power 2 1 divided by 1 by 2 factorial. And so we can have here what we'll have e to the power minus 1 is common 1 plus 1 2 and this is 1 by 2 1 plus 2 plus 1 by 2 and so we will have 5 by 2 into e to the power minus 1. So if you simplify it you will get it 0 0.9197 0.9197. Now let me go to the first one. First one is 1 minus probability x less than 2. That means 1 minus probability at x equal to 0 plus probability at x equal to 1. And so what we will get 1 minus at x equal to 0 is e to the power minus 1 plus at x equal to 1 means e to the power minus 1. So 1 minus 2 e to the power minus 1 and that will be nothing but 0.2642. 0.2642. So these are all probability of defective items in the pocket of 20. Now we have such how many such pockets? We have 1000 such pockets. So what will be the probability of getting exactly two defective items in the pocket of 1000, right? Therefore in the pocket of 1000 the number of of defective items are nothing but first one is n into p x is greater than or equal to 2. That means 1000 into 0.2642 and that is equivalent to 264.2 and that is approximated as 264. Similarly, second one will be exactly two defective items in the consignment of 1000. That means 1000 into probability of x equal to 2. So 1000 into probability of x equal to 2 is how much? That is 1839. So 0.1839 and so 183.9. So we can approximate it, we will get 184. And the third one is 1000 into probability x is less than or equal to 2. Less than or equal to 2. So greater than or equal to 3. 3 is x less than or equal to 2 and that means 1000 into that value is 9197. So 0.9197 and that is nothing but 919.7 and it will be approximated as 920. Okay, so like this we can find the probability for a Poisson distribution. In next another important question I will do. So fitting of how can we fit the data with a Poisson distribution? How can we fit the data with a Poisson distribution? So right here, like binomial distribution, we can fit the Poisson distribution also. So fit a Poisson distribution where the data are given, x and corresponding frequencies are given 0, 142, 1, 1, 5, 6, 2, 69, 3, 27, 4, 5, 6, 1, and total is nothing but 400. Okay, so whenever you are getting like this question, you understand that you need to find the theoretical frequencies. So in order to find theoretical frequencies, we will approximate the given data through Poisson distribution. Okay, and in order to find the Poisson distribution, we need to find lambda. So how can we find lambda? Lambda can be found in this way. Lambda can be found in this way. We can find the mean of this given problem. So first find the mean of the given problem, x f into x. So x equal to 0, f into x will be 0. X equal to 1, f into x will be 156. X equal to 2 and fx will be 138. Fx will be 138, 138. And x equal to 3, this one will be 81. This one will be 81, and x equal to 4, this one will be 20. X equal to 6, this one will be 6. So total will be nothing but total will be 400. Here locally you are getting this is also 400. Sum of the frequency is, so this is my sum of f and this is my sum of fx. Now what I will do, I will find average equal to summation fx divided by summation f. So 400 divided by 400, that is 1. And this average is nothing but mean. This average is nothing but mean. So we got lambda. We got lambda. Okay. And you know the value of small n also. You know the value of small n also. So this is lambda equal already. Lambda is given. Now what we do? We know to fit the Poisson distribution, or to fit the Poisson distribution, we use what we use n into e to the power minus lambda, lambda to the power r divided by r factorial. But what is your lambda? Lambda equal to 1. And what is your capital N? Capital N is given here. Capital N is nothing but 400. This is equivalent to 400. Capital N also. Capital N is 400. So how can we do it? We can have here 400 into e to the power minus 1 divided by r factorial. Divided by r factorial. Lambda is 1, 1 to the power r is 1. So that one no need to write. This is the thing we will put for basing on the value of x. So now what I will do, I will find out the theoretical frequency here, x and f. Theoretical frequency I am finding. So what will happen when x equal to 0? That means r equal to 0. So I can have here 0. R equal to 0 means 0 factorial 1. So I will have 400 into e to the power minus 1. Okay. And this one will be 1. I will have again 400 into e to the power minus 1. And when I will have 2, I will have 400 into e to the power minus 1 by 2. when I will have 3 here, 400 into e to the power minus 1 by 3 factorial, and where I will have 4 here, 400 into e to the power minus 1 divided by 4 factorial, and when I will have 5 here, this is not 6, this will be 5, this is 5, sorry, this will be 5, this will be 5, this will be 5. Okay, sum will be 400. Okay, and so for 5 we can have 400 into e to the power minus 1 divided by 5 factorial. So if you simplify this, what we will get? We will get, if we simplify this, we will get 147.15. 147.15. If we simplify this again, 147.15. And if we simplify this, we'll get 73.58. 73.58. And if we simplify it, we'll get 24.53. If we simplify it, we'll get 6.13. And if you simplify it, we'll get 1.23. 1.23. So this is the theoretical frequency, but this is not the final one. We have to truncate these values, and finally you have to write x and f by truncating them. Therefore, the the theoretical frequencies are given as below. 0. So 147.15 can be approximated as 147. 1. Again I can approximate this one, I will get 147. And 2. If I approximate to 73.58, I will get here 74. If I approximate 24.53, I will get here 25. If I approximate 6.13, I will get here 6. If I approximate 1.23, I will get here 1. So you please try to find the thing. Definitely the sum will be 400. The sum will be 400. So like this, we can able to fit a given data with the Poisson distribution.